So you can see my screen or not yet? I guess you should be able to see it now. Okay, can you see the screen now? All right, so I think this has a common chat, right? Everyone can hear everyone, and this is more like what we had earlier. All right, so let's just minimize this. Okay, so all right, so what's my plan for the remaining of the statistics course? Uh, we have four of the homework parts in statistical inference, and I thought I'll just cover through each of these today, and that will kind of clear up the concepts as well as kind of be a reminder for whatever we've done in this course so far, because there would have been a huge break, right? So everything will become just as a reminder one more time. Okay, so we'll do that. All right, so uh, I think straight will jump to homework, week two homework, or do you want to do even the week one homework questions? So, for example, these are the questions. Have a look at the questions. We will kind of, discuss them in the class, and then we'll see what we need to do more. Uh, in the meantime, let me just start another software. Mm, sorry, I think I've covered up. I think you can see me now, right? You can read the questions. You did this, right? Yeah. So you guys remember it, or do I need to kind of repeat it? I mean, here's the link. Let me send you the link. Have a quick look at it. Otherwise, we'll just straight away jump to second week. I mean, I sorry, I think I've sent you the wrong link. Have a look at it here. In the meantime, let me just set up another software so that or shall we just yeah, so yeah, ask them. Utkarsh, Dipankar, you want me to go through these questions? Not needed? All right. So second week onwards we'll start. Okay. So look at these questions. Uh, now just go through the question. Don't look at the side of the sheet. The probability that a manuscript gets accepted to journal is 12%. All right. So a probability of some event happening is 12%. However, given that a revision is asked for, the probability that it gets accepted is 90%. So the probability that an event occurs before this event, then the probability of this event occurring is 90%. So is it possible that the probability that a manuscript has a revision asked for is 20%? So what are we saying here? We're saying that it is given that probability of A is 0.12, right? 12%. And probability of A given R is 0.9, 90%. Then is it possible that probability of R is 0.2? All right. How do you go about solving this question? So I would like to give you mic rights, but the feedback loop and the noise is creating problems. Let me just try it out anyways. So you have the mic rights, but I can see the feedback. I can hear the feedback. You can also hear the feedback loop.
स्पीकर यूज करेगा तो प्रॉब्लम नहीं होगा, ईयरफोन यूज करेगा प्रॉब्लम नहीं होगी, ठीक है। Well, we'll use earphones. Just wait, then we'll try it again.
अभी ठीक है, एकदम ठीक है. I think दीपांकर का तुमने
हाँ
म्यूट किया.
दीपा
So if Dipankar and you are sitting in the same room, then there's no need to have two
हाँ
mics, right? One is good
हाँ,
enough,
that is also true.
right? So I can
No, but
anyways,
he'll not be able to hear you,
I
no?
can I can hear
Yeah,
you.
thank you.
I can hear Dipankar even through your mic. Mics typically have a large, audio catching capabilities. I mean, range. They have a large range.
Okay.
Yeah. All right. So this is the thing. Let's see how do we solve it. Basically, we use what's called the Bayes rule and stuff like that. So probability of A given B. I think
Hmm.
Lavita has already answered this. Is equal to probability of A as well as B divided by probability of B, right?
हाँ,
So we're going to use this
probability of
concept. Let's
B.
have a look at it. So we say, okay, let's first just look at it graphically. We're saying probability of A and probability of R, right? And then this is probability of A and R both happening, right? So then what can we tell about the probability of R individually, right? So probability of A uh, is equal to probability of A with R plus probability of A without R, right? So
Yes.
is this clear? So that is this portion as well as this
Yes, bro.
portion, right? So then probability of A can be written as, if you look at this part, we can say it is equal to, so this is what Lavita has written, right? So probability of A given R into probability of R, all right? So because the probability of A and B is equal to probability of A given B divided by probability of B. So that is probability of A given R into probability of R here, right? Fair enough. So we use whatever Lavita has written, same formula we used, and and this is a
Yes, correct.
right. So similar thing we do it for here, right? Probability of A given not happening of R into probability of R not happening. All right. So let us see what we get. So we are given that probability of A is 0.12, right? Now probability of A given R is zero point 0.9 into probability of R.
भैया, the place where you're writing, I cannot see that. वो side में shift हुआ हुआ है.
अच्छा नहीं, मैं लिख नहीं रहा हूँ ये स्क्रीन ऑलरेडी दिख नहीं रहा है क्या तुम्हें? होमवर्क 2 लिखा हुआ है जिसपे.
नहीं, मेरे को नहीं दिख रहा है. दीपांकर वाले में दिख रहा है. ठीक है, I'll see it from Dipankar's laptop. Okay, okay.
I think something that you need to set probably. You need to make it maximized or something maybe.
इसको एक चैट को राइट. ओके ओके, हाँ ठीक है, हो गया.
10 minutes up.
Right?
हो गया हो गया.
Right. So we just expand this basically. That's all we're doing. We've written the formula first like this, and then we are expanding it. Right. So we say probability of. So you can ask questions wherever you not clear, because that will kind of take care of everything for the course. Any questions through these homework part will take care of everything for us. All right. So so this is it. So is this clear how we expand it, or do you
हाँ
want me
भैया.
to? Right. So let me just redo this here. So I'm saying probability of A is equal to probability of A intersection R plus probability of A intersection not R or tilde
नॉट
R.
ऑफ
Okay. Now this, according to Bayes rule, would become probability of A given R into
गिवन
probability of R. All right. Similarly, this will become probability of
ओके.
A given not R into probability of not R. Right. And we know some of these probabilities. So we say 0.12 is equal to, now this is given to us, it is zero point 0.9, all right, into some x. We don't know this value. We say x, okay, plus probability of A given not R. How much is that? That we know.
Accepting
It's
given it
point,
cannot be revised.
right? It is going to be, no, no, we don't know this, right? But let's
We
say
don't know that. हाँ.
this is some positive value,
Why?
right? So it will be some
Okay.
positive value or at max zero, right? So it is greater than equal to zero.
Hmm.
right? So there is some, let's call it some y, all right? Now, and this y is
Hmm.
positive. Now, what can be the maximum value if you were to maximize x? This is what we are interested in, right? If you were to maximize x, value of x can be maximum if y is 0,
Hmm.
right? Because,
Right.
right, so let us, for the simplicity sake, assume this part to be 0, which means what is the maximum value of, what is the maximum value of x that I can get? So x max is equal to 0.12 divided by zero point 0.9, right? Which is
Hmm.
definitely less than zero point 0.2, right? So this comes out to be maybe 1.135 or something like that, whatever it is, 4 by
Hmm.
3. Yeah, 133, right? So that is definitely less than
Right.
zero point 0.2. So we can clearly say that this is not possible, right? So the probability of revision being asked cannot be 20% because it cannot be more than 0.133 for these conditions to be held true. So in a way, very simple question, but a little tricky one,
Yes. Yes.
right? So if you just look at the question, you say, how can you actually tell anything about this probability just by knowing these two probabilities, right? So we say, okay, not possible at all. And let's look at the answer. So he's using the same concept. Okay. I think he's explaining it in a different manner. He says probability of A intersection B is equal to probability of A given B into probability of B, right? So in this case, uh, uh, he's just multiplying it by zero point 0.2, then he gets 0.18, right? Which should be actually what? Probability of A intersection B,
This is
right?
larger than.
And this is larger than probability of A. Again,
It's
he's
not
saying
possible.
A intersection B cannot be larger than just the probability of A, right?
Right.
0.18, that this is larger than, yeah, 0.12. Why is it bothering about 0.12? Yeah, 0.12 is the overall probability, right? Right. So a smaller
Hmm.
portion of A cannot be larger than 0.12, right? So here the smaller portion, if we were to consider zero point 0.2 as correct, then the smaller portion of A itself is showing out to be 0.18. So which will definitely not be possible
Hmm.
because A intersection B is a subset of A,
Right.
right? So this is another way to explain the same question. Okay, so let's move ahead. Suppose that the number of web hits to a particular site are approximately normally distributed with a mean of 100 hits per day and a standard deviations of 10 hits per day. What is the probability that a given day has fewer than 93 hits per day expressed as a percentage to the nearest percent point? So what are we talking about in this question? We're saying mu is 100 and sigma is 10,
Hmm.
right? And so this is 100. So we're talking about this area under the curve where the value is less than equal to 93, right? Has fewer than 93 hits,
Right.
right? So we are interested in this area under the curve. So I think if we just straight away use the p norm, right? If we were to say, let's look at it. Hmm, I think this is too small for you. Let me just make the size larger. Can you read this now? Can you read my? Uh, s-
Yes.
okay, so p norm is what we are interested in. What is he saying? What's the probability, right? P norm for a q
Hmm.
which is 93 or less, all right, given a mean of 100 and a standard deviation of 10, and then of course lower order tail is true, so we get 0.24, right? Then he says express it as percentage, then this is the answer, right? 24, and we say submit, correct. So what is the logic he's using? Similar, right? He's just straight away multiplying it by 100 here. So is this clear, Dipankar? Was it clear to you? Do you understand the okay,
Phenom, yes.
all right. So suppose 5% of the housing projects have issues with asbestos. Now this is an interesting question, all right? So basically you use asbestos as a material and there's a problem with that. Now the sensitivity of a test for asbestos is 93% and specificity is 88%. Now, how are sensitivity and specificity defined? Let's look at it. So, okay, this is done.
Okay.
So, the probability, let's say A is some event, which is in this case issue with asbestos, right? So, the probability of A happening is 0.05. Sensitivity of some value, which means probability of the test showing it up as positive, given that that particular, I mean, let's look at it from the case of the HIV case, right? So we say overall in the population,
Mm-hmm.
5% of the people can have the disease. And then if given that the person
Mm.
has the disease, what are the chances that if you do the test, it will show up as positive, right? So that is 93%. Similarly, specificity is the
Right.
reverse of that. Given that somebody does not have the disease, what are the chances that the test will show up as negative? So that is 88%, right? So in this case, so we're saying the probability of the asbestos happening is 0.05. So given that the house has an issue, the project has an issue with the asbestos, what is the probability of the test showing that yes, this house,
It's 96.
yeah, so that's what it is. So now the question here is, what is the probability that a housing project has no asbestos given a negative test, right? So that's all. So basically, we have to find out what is that we are interested in. We are interested in this. Given that the test shows up negative, based on these values, what is the probability that in reality also the house doesn't have asbestos, right? So otherwise, we say okay, if we just look at the test, I mean, we do the test, then 95% of the houses don't have asbestos issues. 5% have issues, right? So if the test shows up negative, then chances are that it is 0.95, right? But that doesn't really add anything other. I mean, then there's no purpose of the test, right? So we're saying, do we get anything better? Are you clear on this? So by
Yes,
just
yes.
knowing the PA, then we are saying that only 95% at max will not have the asbestos issue, right? So if the house test negative, what is the probability that house belongs to 95? I mean, that it does not have this problem. Okay. So how do we solve this? Again, we expand it. We use the simple, again, just what we did earlier is what we are doing here, right? We're saying,
Mm-hmm.
let's, if this equation is not clear, I will explain it here. Let's just do it this way. Um, let's say, so probability of some event happening, let's say probability of an event B happening. So before event B happens, either event A has happened or event A has not happened. All right, only two possibilities,
Yes, sir.
right? So now
Where this equation is clear to me.
this is
I
clear to you.
think
What the
Dipankar ko,
others?
if it's not,
Dipankar, Lavita,
this equation is clear to you. Yeah. Where Dipankar to be also is okay with the equation.
yeah, Lavita, is it clear to you?
10 minutes up.
Lavita, I didn't hear any response. Is she there?
लास्ट टाइम में लेट रिस्पॉन्स किया था तो हो सकता है शायद कुछ
Me
लैग
too. This
हो.
is same. Yeah, actually, it's Bayes theorem exactly, right? So this is what we have.
Yeah.
Now this is what we are interested in finding out, right? So now probability of minus is given by these values here. We already have, in fact, all of these values. So probability of minus given A, what would that be? If probability of plus given A is 0.93, then definitely probability of minus given A is 0.07, because it is 1 minus this probability.
Hmm.
Yeah. And then probability of A is known to
Right.
us, 0.05. Then similarly, this probability is known to us. Probability of minus given tilde A, that is 0.88, right? And probability of A tilde A is 0.95, because probability of A is 0.05, right? So that will be 1 minus 0.05. So this probability comes out, so probability of minus individually comes out to be this value, whatever it is, 0.8395. Okay. So now we are interested in this value. Now this value is nothing but this formula, again based on the Bayes principle, assuming that they are not uh, uh, correlated, right? So
Independent in हाँ
yeah,
independent
independent,
variables.
right? So they are independent. So then this is given by probability of negative given, so basically specificity values here, right, into probability of A not happening divided by probability of minus. So if you do all these calculations, you get a 0.9958, right? So if you get this as an answer, he says as a percentage point, what will be the correct answer then? So
9 and 5 8. 100% is
right,
right.
100%, right? So if we submit this is correct. Let's have a look at the answer also. So he's doing the same thing. He's just doing those calculations and showing it up. All right. So is this clear? So
Hmm.
basically the point is that you should be able to uh, okay, let's move to the next question. Suppose that the number of web hits to a particular site are approximately normally distributed with a mean of 100 hits per day and a standard deviation of 10 hits per day. What number of web hits per day represent the number so that only 5% of the days have more hits? All right. So, so this is what we want to find out. What number of web hits per day represents the number so that only 5% of the days have more web hits. So what will that be? So this is our question, right?
Q
State,
Q.
yeah, right. So
You can
we
take
just want to
example
find
G
out
value, right?
the Q norm. Q norm with
Yeah,
what
yeah.
values, right? Q norm with so it'll be Q norm. All right. So now this 5%
With
here is 0.95, right? So I can say
yes, yes.
0.95, comma, mean is 100, comma, standard deviation is 10, right? Comma, lower dot tail is false or true
It's true.
in this particular case? False, right? So,
Wo-
sorry,
The
no, no,
lower tail exactly tail से
sorry. Lower dot tail would be true because yeah, it'll be true because from this side we start ending up adding the probability. Look at it. If you were to do cumulative of this, right? So how lower the tail or oops, let me not do it here. Let me do it here. How lower the tail or upper the tail works is this way. Say this is your normal distribution curve, right? So you start ending
Hmm.
adding up from minus infinity. Area under the curve, this is what is adding to the probability, right? As you keep on adding,
Hmm.
when we say 95%, 95% will be always this way, right? Even if it is 25%, that will also be this way. So we wanted 95%.
Hmm.
This is 95%, right? We didn't bother about 5%. We said 95%. Is this clear now? Why lower the tail is true?
Right, bro.
Yeah,
Yeah.
right. So if we had done it the other way,
बट
then we,
भैया
yeah.
बट लोअर डॉट टेल को फॉल्स कब करेंगे फिर वो तो
लोअर और
हमेशा
टेल
ही
को
ट्रू
फॉल्स
रहने
सुनो
वाला
सुनो
है
सुनो सुनो जब हम कह रहे हैं कि ये वन माइनस ये प्रोबेबिलिटी लेनी है तब लेट अस लुक एट द सेम थिंग हमेशा ट्रू नहीं रहेगा से अभी इसी केस को ले लो अब जब वो क्वेश्चन फ्रेम हुआ था इट सेज सो दैट ओनली 5% हैव मोर राइट तो मैं इसको 5% के हिसाब से करना चाह रहा हूं मैं कहता हूं 5% अब मेरे पास आंसर वही आए नाउ आई वुड से लोअर डॉट टेल इज इक्वल टू फॉल्स आर यू गेटिंग इट सेम आंसर बोथ साइड्स
अच्छा ओके ओके
क्लियर
तो
नाउ
कौन सी साइड से वो गिनेगा परसेंटेज को
naturally when we are saying lower dot tail is equal to false what it means is the
वो
implication
लेफ्ट
itself
साइड
is
राइट साइड से
exactly it will start calculating from here like this probability but know that finally it is always going to be from minus infinity to infinity when you integrate right low value to upper value typically
हम्म
right so you're saying low value to some x so this integration minus infinity to x is going to be your probability okay so cumulative density function is typically always going like this it never goes like this you don't add the values like this right? So it is always
राइट
going.
राइट
This is the area under the curve. What does lower dot tail mean? Mathematically, all you're saying is that instead of this, I can subtract it, right? I can say 1 minus that probability. That's all. So lower
ओके
dot tail is equal to false just means this 1 minus the probability, and then that 1 minus probability is equal is again to be calculated this way and not this way,
ओके
right? So
ओके
all right, okay. So now so we have this one. What were 116, right? So yeah, so he's doing the same thing. Hmm. So he's done it both ways. In one case, he's used the lower dot tail is equal to true, in the other case, he doesn't. in one false and true, right? Okay, so let's move to the next question. All right, so suppose that the number of web hits to a particular site are approximately normally distributed, again 100 hits per day and a standard deviation of 10 hits per day. Imagine taking a random sample of 50 days. What number of web hits would be the point so that only 5% of the averages of 50 days of web traffic have more hits? All right. So what are we saying? So first of all, everything else seems to be similar to the previous question. Only difference is
Hmm.
this time
Random samples.
I'm taking random sample of 50 days. And what is he interested in? He's interested in the averages of the 50 days, right? So I want to take the average of the 50
Hmm.
days. If I were to take the average of the 50 days, right? Uh, what would be my standard deviation? Like, say my standard deviation in general is 10, right? So what would end up becoming the standard for per day? It's 10. So what will end up becoming the standard deviation for this situation? It'll end up
Under
becoming,
root 50, say
right? So under root 50, right? So that's all.
10 divided by.
10 divided by square root of 50,
Yes.
right? So that's all I have to do. So I'm saying q norm 0.95 100 10 divided by square root of 50, right? So that's what takes care of my this question. Is this clear?
No, but imagine. Just please wait. Can you take it?
Yeah, I'm keeping it as it is. Whatever is not clear, we will go through it properly. So this is the question here.
Okay. ठीक है.
So is this clear to both of you also? Yeah, Lavita, tell me.
Hmm.
How do you, okay, so Lavita had a question in the previous one. How do you know whether it is one-tailed or two-tailed? Let's go back. So I guess this is the one that you're talking about, Lavita. Which one? This one, right? So that only 5% of the days have more hits. This is the one. I guess this is the question. So let me start explaining this. In the meantime, Lavita would respond back. But is it that what she meant? All right. So like, all right. So why am I take 5%? Why only this side? Why am I not taking 2.5% this side and 2.5% this side? Okay. So would you like to answer this? I normally it can be two-tailed also, right? 2.5 this side, 2.5 this side. Why 5% only
ऐसे
one
कैसे
side?
होगा?
हाँ ठीक बात. क्यों नहीं होगा? दो इट सीम्स ऑब्वियस क्यों नहीं होना चाहिए, बट फिर भी जरा देखो कि क्यों नहीं होगा.
Cycle is not it's more.
10 minutes up.
क्योंकि more लिख रखा है ना तो it should be
Exactly, right?
on the.
So that days have more hits. The moment you have more hit means more hits than a particular number. या तो less होता, it either it would have been saying either less than or more than a particular number. Then it is only then it becomes two-tailed. The moment it's saying more, that means it has to be one-sided, one-tailed. Is that clear, Lavita? Lavita is not responding. Is she there? I see her offline actually. I think she has a problem with her laptop.
I think उसका हाँ कुछ lag चल रहा है वो हमेशा respond भी थोड़ा धीरे हो रहा है उसका.
उसका विंडोज मशीन है, मैक है?
Windows है भैया उसके साथ laptop में प्रॉब्लम है बहुत slow चलता है actually.
Hmm. Okay, so let's move on to the next question. So we've solved this. Uh, okay, Lavita, are you there? Okay, now again, this is a very interesting question. You don't believe that your friend can discern good wine from the cheap one. All right, so he cannot tell you whether it's a good one or a bad one, right? So assuming that you are right in a blind test where you randomize six paired varieties, right, of cheap and expensive wines, right? So in each pair you have one cheap and one expensive one, right? And your friend doesn't know which is which. Okay, so he's asked to guess it, right? So what are the chances that he or she would get five or six rightly expressed, right? So that's the question. Is the question clear?
Okay, so six paired. 12 of them. What is the chance
No,
that
no, not
she
12.
gets five
It's
or six? To
so
the percent, one decimal place.
yeah, forget that part, right? As a percentage to one decimal, forget. I want you to understand the question. Say if I explain it, then it becomes obvious. It'll stop your thinking. I would like you to think on your own on this question.
Okay, okay.
So while I wait, you think about it. The moment you think it's clear to you, explain it back to me. Yeah, Lavita, you can't hear me? I don't think Lavita can hear me. What to do? She should, I think, change her laptop or reinstall Windows.
What is the change that she get five or six right expressed?
What is the change? That's a
If that change,
change. No, it's a chance. What is the chance?
chance, हाँ,
Right?
50% मतलब 0.5 या तो 5 सही होगा या 6 सही होगा.
No, no. First, understand the
हाँ,
question. What is the question talking about? Let's say, what's the question saying? Question is saying
कि there are 6 pairs of wine.
six
Uh,
pairs, right? Let's say, uh, let me make it simpler. Let's say you can't decide. See, you're blindfolded, all right? I
mm,
cover your eyes, okay, and I toss a coin, and I ask you whether what we've got is heads or tails, right? So, and I toss the
हाँ,
coin six times. One, two, three, four, five, six. All right. So, first times you give me some answer. All right. And let's say your answer is correct. So, your answer is right or wrong.
okay,
Right. Second time you gave a wrong answer. Third time you gave a right answer. Fourth time you gave a right answer. Fifth time you gave a wrong answer. Sixth time you gave a right answer. So, in this case, how many times did you get right? Four times. Right. If you ended up giving, say, you got five times right. Right. If every time you ended up giving it correct, you got it six times right. Is this fine? So chances
yes,
are that you would have only one right. Actually, you will have zero right, one right, two right, three, four, five, and six. Have you got this question? Don't look at this question. First, understand this question.
yes,
Yeah, both of you understood this. Dipankar also
yes,
understood this.
yeah.
Yeah. All right. So now I'm saying, what is the probability of getting this? Then what is the probability of getting this? Probability of getting this? Probability of getting this? Probability of getting this? This, right? And then if I was to say what is the probability of getting five and six, I just sum it up. The two probabilities here,
Mm,
right? Probability of each of
mm,
this is one. So I can probably find out the rest of the probabilities and subtract one, right? So this is one way to look at it. Now let us look at it. How does this particular question combine with the question that we have at hand? Now our question is, so we have a pair of wines, right? So I will show six pair of wines to you, let's say, right? And you don't know which one is the cheap one or which is the expensive one, right? So if you were to only tell which is the cheap one, which means the other one is obviously the expensive one, right? So which means
so
cheap, expensive.
it becomes a fair coin.
Exactly, right? So it's equivalent to a fair coin toss situation,
Yes, yeah.
right? So it's like I'm tossing the coin six times. It's equivalent to a fair coin toss, right? So I have a probability zero point 0.5 of he telling it correct, probability zero point 0.5 of he telling it wrong for every toss,
Mm,
right? So if I was to either just I say basically it's a binomial, right? Binomial with six coin tosses, right? And there is a straightaway formula called P binom, right? But I think we will do the maths also behind
mm,
this. So P binom The inputs are, first is how many times or less, right? So in this case 5 or 6, no, so 4 or less, comma, total coin toss is 6, comma, probability 0.5. So this probability would be all of these probabilities, right? So if I was to take only this probability, what can I
Okay.
say? 1 minus all of this, right? So if I come back here, if I say 1 minus this, I would get the correct answer. But mathematically looking at it, what are we talking about?
1 minus this क्यों किया भैया?
क्योंकि मुझे तो असल में व्हाट इज द चांस दैट शी गेट्स 5 और 6 राइट, नो? तो मुझे तो ये वाला चाहिए एक्चुअली, probability of getting either 5 heads or basically 5 times predicting it right or 6 times predicting it right,
हाँ.
right? तो मुझे ये सब probability चाहिए.
अच्छा P.
जो p बाइनोमियल फंक्शन होता है, वो अगर मैंने सपोज यहाँ 4 डाला तो वो क्या करेगा, 4 या उससे लेस का सबका क्यूमुलेटिव प्रोबेबिलिटी मुझे दे
Okay.
देगा, बिकॉज विल से 0 प्लस
Okay.
1 प्लस 2 प्लस 3 प्लस 4. But I am interested in
Right.
5 and 6, so I can just subtract it from 1. Know that this is a not a cumulative density function, it's a cumulative mass function that's going on here.
Yes.
Rather probability mass function and not probability density function. Therefore 4 तक जाने से enough है. पांचवा, because that will be a distinction, right?
Yes, भैया.
Right? So is this point clear? Okay. So if we were to solve this, so he says p is equal to 0.5 and x be a binomial. So he's doing the same thing. Round off of p binomial 4, comma probability of 0.5, size is equal to 6, lower tail is equal to 4, as it is default 10.9. So he's taken lower tail is equal to false here now because he wanted 1 minus p binomial. Yeah, I will do that. Uh, okay. In fact, Lavita, I see that it says not connected to audio. For some reason, you don't seem to be connected to audio. Anyways, she can't hear me, I think. Okay. So, let's redo this. Let's look at it here. Let us look at it this way, right? Let's say he is able to say that it is a good one is good one with the probability of p, and cheap one is cheap one with the probability of 1 minus p. But in this case, both are same, right? Because the friend cannot tell which is which, right? So his probability of going right is
Okay.
0.5, his probability of going wrong is 0.5. Let us say
Okay.
if he tells it right, we give him 1 mark. If he tells it wrong, we give him 0 score, right? So that's same as head and tails, right? So then what is the probability of getting 5 rights? It is 1 upon 2, 1 by 2 raised to 5 into 1 upon 2 raised to 1 into 65, because number of combinations of 5 rights out of 6 is what? 65. And then this is the probabilities of,
10 minutes
Right.
up.
right? Similarly, probability of getting all of them right is 66. There's only one chance out of that. And the individual probability is 1 by 2 raised to 6 into 1 by 2 raised to 0. So you get the answer as 0.109. You will get the same answer with 1 minus p binomial of 4, 6, 0.0.5.
Right.
Okay. So,
Sound.
uh, so okay, Dipankar, please ask your question. What is it?
Um,
Is there a doubt about p binomial? Whatever the question, just shoot it. Whatever is not clear, because it'll otherwise it'll become a nice revision for whatever else might be missing. Okay. So what part you didn't get? How did we convert that question into the binomial question? Right. Uh, what is he saying in the question? He's saying that it's a blind test, just like I said. Let's say I tie a kerchief on Utkarsh eyes, right? So I toss the coin. Now the probability of getting a heads or a tails is equal, right? So that probability is anyways here. But at the same time, probability of Utkarsh telling whether we've got a heads or a tails is again 50-50, right?
yeah.
So So because I randomized, this probability becomes 0.5, 0.5. I've randomized, no. So one thing. Secondly, uh, because the friend also cannot tell which is good, which is bad. So this probability also is so both ways. So don't get confused by this part. Let's just look at this. So probability of his telling it right is 0.5. Probability. Let's say I just showed him one pair, not six pairs, one pair, right? I show him one, say, let's say a fake wine and a original wine. Okay, so but he cannot make out the difference. What is the probability of him uh, uh, telling it right? 50%, right? Is, is this point clear? Is this point clear, Dipankar? So
Yes, but he's saying yes.
similarly, the probability of his telling it wrong is again 50%. If I was to repeat this experiment six times with him by showing him different pairs, right? So one time, say, let's say I showed him a BlackBerry phone, one original, one duplicate. He can't make out which is original. Next time I show him a Nokia phone, which is original duplicate. He can't make out, and so on. So like that, I do this experiment six times. Every time his probability of being right is zero point 0.5 and his probability of being wrong is zero point 0.5, right? So let us say what I want to find out. I want to find out the probability that he is right five times. So let's do that. Right? So his probability of being right five times means what? If I was to assign a, yeah, actually it is minimum five or six, but we will first do five. Then six is obviously easy, right? So let's say if we can just do five times for now, right? So probability of his being right five times means what if I was to assign a, say say for example a score, right? So got it, no? From this from this point, it's further is clear, right? So all this is just maths. Okay, so good. So let's move on to the next question. So consider a uniform distribution. If we were to sample 100 draws from a uniform distribution, such that the uniform distribution has a mean of zero point 0.5 and a variance of 1 by 12, and take their mean. So I draw 100 samples and take their mean. What is the approximate probability of getting as large as 0.51 or larger expressed through? So what is the probability of getting a value which is zero point 0.5 or large 0.51 or larger? So let's look at the question first, right? So we said the sample me the sample has 100 draws, and then I'm taking the mean of it, right? So what is the probability of getting? So this is what I'm interested in. I'm interested in the mean, right? So we know that whether any distribution is uniform, whether it is exponential, whether it is whatever it is, when you uh, take a sample, multiple size sample, right, and then take a mean of that, the distribution of the means will be what? Normal distribution. So even though the original distribution was uniform, the means will have a normal distribution, right? And we also know the property that the new normal distribution of the means will have a standard deviation which is given by uh, standard deviation of the population divided by square root of the sample size. Is this fine? So,
Okay.
so is this point clear to both of you?
So
This is the basis of CLT, right? Central limit theorem. So
yes,
now,
man.
once we know
Yeah.
this, what are we saying? What are we interested in? Let's look at this. So we're saying I'm given that sigma square is 1 by 12, right? Mu is zero point 0.5. I want to find out the probability that x bar, not x bar is greater than equal to 0.51. All right. So so, so I can straight away just use the p norm, right? I say 1 minus p norm
भाई
because
यूनिफॉर्म
yes.
यूनिफॉर्म डिस्ट्रीब्यूशन का वेरिएंस जीरो नहीं होना चाहिए क्या?
नहीं नहीं नहीं
Uh,
नहीं, लेट्स लुक एट इट. सुनो सुनो सुनो. यूनिफॉर्म डिस्ट्रीब्यूशन
I
माने
think
क्या?
I'm confused somewhere.
या लेट मी मीन उसका 0.5 होगा. लेट्स से यूनिफॉर्म डिस्ट्रीब्यूशन is such that value can be anything between 0 and 1, right? This is a uniform distribution. So the mean is 0.5. Now the value can be equally distributed, right? So it can be 0.25 also. It can be 0.75 also,
Okay, okay, okay.
right? So let's
Yes,
say
sir.
10 values. for simplicity's sake, let us say 10 values, and the values are, or rather 11 values: 0, zero point 0.1, 0.2, 0.3, 0.4, 0.5, all the way till 1, right? So they're equally distributed.
Hmm.
Each of them, let's give a equal probability. Hmm? So then what happens? So now their mean will be zero point 0.5,
Yeah.
but their standard deviation will not be zero point 0.5, because I say zero point 0.1 minus zero point
Right,
0.5
right,
square and
right.
so on, right? Clear on this?
Yes,
In
sir.
fact, it is
Yes.
always the variance of a uniform distribution is always 1 by 12. You can actually mathematically prove it.
Okay.
All right. So it's not a big deal. So mathematically, you can prove that the variance of a uniform distribution will always be 1 by 12. Anyways, right? So, so we say that we have the normal distribution. So now what are we interested in? We're saying that we are interested in, say, a curve like this, where we say, okay, what's the approximate probability of getting as large as 0.51? So this is zero point 0.5. All right. This is 0.51. We are interested in this area. Okay. But know that this 0.51, this 0.51 is for the mu bar, right? This is a normal distribution. It is not a uniform distribution. We had a uniform distribution which was the population. This is for the sample means, right? So sample means will always have the expected value of the probability. Sorry, the expected value of the mean will be still the same. So if this was zero point 0.5, this will also be zero point 0.5. But the standard deviation will be given by standard deviation of the population distribution divided by square root of n.
Number of
Exactly,
digits.
right? So in this case, we are given square. What are we provided? We are given the variance, which means square sigma square is given to us, which means sigma is what? 1 by 12 square root, and then I divide this by square root of 100, that is 10, right? So basically it becomes 1 by this, right? So this is my
Square root 10.
sigma.
Yes. Yes.
So if I was to put this into my p norm function, I say p norm of 0.51 comma zero point 0.5, 1 upon, that's the standard deviation, and then the lower dot tail is equal to false by default, right? So I just subtract 1 from this, so I'll get my answer. Or I can say lower dot tail is equal to, yeah, so I need to say lower, by default lower dot tail is equal to true. Either I say lower dot tail is equal to false, that's how I get the correct answer, or I subtract it from 1. Both ways it's the same thing. Is this part clear? Something is not.
Yes.
Dipankar, is it clear to you?
Yeah.
Okay. All right. So that's what he's doing, right? So, all right. So let's move ahead. So, so if you roll 10 standard dice, take their average, then repeat this process over and over and construct a histogram. What would it be centered at? Okay. Read up the question. Think about it
If
and
you
tell me.
roll 10 standard times, you get three.
10 minutes
Take
up.
the average. Then repeat the process over and over again. Construct the histogram. What would be centered? Centered average. The average only.
The average of what? Your answer is possibly correct as long as you define what is your
Ten
average.
standard dice. Okay. The average of the 10 standard dice, yes, the Pankaj.
So what is that?
Uh, एक minute. The average of the 10 standard dice would be mm, 10 into average of one standard dice, and average of one standard dice is 1, 2, 3, 4, 5, 6,
Okay, let me make it simple. Average of one standardized is
3.5
3.5
into 10.
into 10. That will be your answer, 35.
In, 35 is the average of 10 standard dice, and it will be the average of the histogram also.
Oh, okay. Just check out what mistake you've made. Read the question again.
Take the average and repeat the process over and
So
over
that means
again.
35, right? Let me just say
And
submit.
constant.
I get a wrong answer.
Okay. See, basically, he's going to take a summation of all 10 dice. Huh. So you have anything between 0 to 60 being played 10 as many times. But the average that is repeated again and again. And it become a histogram. So histogram is frequency. Okay. Should it be 30? So what should be centered at?
Read the question. No, no, no. So if you roll 10 dice, where is he saying he's summing up them? Does he, nowhere is he mentioning that. He's just rolling 10 dice and then he's taking their average.
Okay. Yeah. नहीं बट 10 डाइस का अच्छा ओके एवरेज
He
फाइन
rolls
डिवाइड बाय 10 भी तो होगा
10 standard dice and take their average. Then repeat this process over and over. So answer should be 3.5 only, right? Because he rolls the
5
die.
only right
ठीक है ना?
yeah
Yeah, so this again, be careful about. See, once you've understood the concept, then the maths behind it is not difficult. The whole idea is to construct that statement English to maths correctly.
yes
All right, all right. So now, so if you roll 10 dice, to read this question properly, take their average, repeat this process over and over, and construct a histogram. What would be its variance expressed to three decimal places? First of all, what is the variance for one die?
variance for one die is 1 by 12
1 by 2?
1 by 12 वो यूनिफॉर्म
No, no, no.
डिस्ट्रीब्यूशन था
That's uniform distribution. This is not uniform distribution.
वन
Uh,
डाई का
huh.
तो 1 by 6 is the probability of getting anything
Right. Not anything. 1 by 6 is uh,
मतलब
the probability of getting either 1 or 2 or 3 or 4 or 5 or 6. So uniform distribution is
हाँ
continuous distribution, whereas a die roll is a
तो
discrete distribution.
discrete
Right.
so okay it will not be
So how
okay
will you calculate? Simple, no?
to calculate
Yeah. So basically your values are, so so you have values between what?
3.5
1 to
minus
6, right? Subtract them from 3.5.
हाँ
Square this up, right? So I'll square it up,
right
and then divide it by 6. This should give me the
yes
variance, correct? Sorry, I have to sum it up.
yes yeah
Sum this up, all right? So I take the sum and then divide it by 6. Wait, I made a mistake somewhere. Yeah, so my variance is 2.9, all right? So now this is the variance
right
for a single die. Here, what is it? Again, take the answer. Look at the question. What is he asking for? So what will be your answer?
सिंगल डाई का लेकिन 10 डाइज रोल करने हैं, तो take their average repeat this one number again what would be variance variance भी सेम ही रहेगा क्या
He's saying you roll 10 dice, take their average, right? Then repeat this process over and over and construct a histogram. So this is equivalent to the central limit theorem, right? So if the variance of one single die roll is 2.91, now my sample size is 10. and I'm taking a mean of that,
Hmm.
right? So that means it
Hmm.
has to be divided by, the variance has to be divided by 10, the sample
10.
size, which is 10. So, and he's
10.
asking for the
Okay.
variance. So therefore my answer will be 0.291, right? Or 0.292,
But we are doing it again and again and then constructing a histogram. और
right?
फिर
So
उस histogram का variance देना है.
नो नो, हाँ, हिस्टोग्राम का वेरिएंस नहीं है। हिस्टोग्राम इज जस्ट टू शो कि वो छोड़ो, हिस्टोग्राम बनाने की बात छोड़ो। वो क्या कह रहा है कि what will be the
Okay.
variance, yeah, he's saying the variance as shown by the histogram, variance as shown by the histogram, if you measure that values, right? You say, you keep on rolling the 10 dice, take their average, okay? Whatever you answer you get, you keep on noting that, just like in the previous case. So basically it should be very
Hmm.
close to 3.5 actually, तो आंसर 3.5 के पास आता जाएगा। तो look at it this way, I rolled the die, पहली बार रोल किया 10 डाइस, राइट, आई गॉट सम आंसर्स, ठीक है, और उसका एवरेज आया 3.2, ठीक है, फिर से रोल किया, उसका आंसर आया 3.6, फिर से रोल किया 3.5, ऐसे करके आता रहा, ठीक है। सो आई एम प्लॉटिंग दीज, सो मैं इसका वो बना लेता हूँ, फ्रीक्वेंसी डायग्राम बना लेता हूँ, राइट, से फिर से आया 3.5, तो मैं फ्रीक्वेंसी डायग्राम अगर बनाता हूँ 3.5
तो
3.6,
normal distribution आएगा.
राइट, तो नॉर्मल डिस्ट्रीब्यूशन आएगा, राइट। ये जो नॉर्मल डिस्ट्रीब्यूशन
हाँ.
होगा, इसका हमारे को प्रॉपर्टीज क्या पता है, एक तो स्टैंडर्ड मीन विल बी स्टिल द सेम एज द इंडिविजुअल मीन, राइट, वो तो वहीं पे सेंटर्ड हो जाएगा, विच इन दिस
Correct.
केस इज 3.5, mean would be that, what would be the standard deviation, standard deviation would be the standard deviation of a single die roll, right, divided by, in this case, the sample size, which is 10, that will be my standard deviation,
No, 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 भैया, no.
okay।
10 तो सी, ये जो आपने नॉर्मल कर्व बनाया है,
हम्म
इसके अंदर एक पॉइंट जो है
हम्म
वो रिप्रेजेंट करता है 10 डाई का 3.5 जो है या 3.6 जो है.
एग्जैक्टली,
तो इसके अंदर एक, हाँ, तो अब
परफेक्ट परफेक्ट, 10 डाई का एवरेज लिया,
वो,
वो एवरेज लेने से ही तो वेरिएंस कम हुआ ना,
हाँ
एवरेज,
भैया.
समझ गया ना। एक्चुअल जो डाई था, लेट अस से कि वो जो एक्चुअल डाई था, ये वाला एक्चुअल डाई था, लेट से जब मैं उसका एवरेजेस लेता रहा तो वो ऐसे बन गया, कुछ तो क्लोज हो गया, centered around the mean, but it became
हाँ
closer to each other,
हाँ भैया.
right? So that is why we are,
बट अभी मैं क्या कर रहा हूँ,
हाँ,
नहीं, हिस्टोग्राम का वेरिएंस निकालने के लिए मुझे ये sigma under root 10 whole divided by under root of n, which n is the, ये जो over and over repeat किया ना इस प्रोसेस को, वो कितनी बार रिपीट किया है वो
नहीं नहीं
आएगा
नहीं
उसका
नहीं,
मीन.
वो ओवर एंड ओवर रिपीट करने से ही
10
तो
minutes up.
अ, ये फॉर्मूला अप्लाई होगा, नहीं तो ये फॉर्मूला अप्लाई नहीं होगा, नहीं तो नॉर्मल डिस्ट्रीब्यूशन ही नहीं बनेगा ना। ओवर एंड ओवर रिपीट का मतलब क्या हुआ, ही इज जस्ट टू टेल यू दैट इट विल बिकम अ नॉर्मल डिस्ट्रीब्यूशन, once it becomes a normal distribution, only then I apply the CLT. Once I apply the CLT, then I know this sigma divided by square root of 10, नहीं तो अपने आप से, अभी मैंने दो बार किया, लेट से 10 का सैंपल लिया, फिर से 10 का सैंपल लिया, इसका एवरेज लिया, इसका एवरेज लिया, राइट, एक बार 3.56 आया, एक बार 3.4 आया, मैं इसमें से कुछ भी नहीं कह सकता हूँ, व्हाट कैन आई से अबाउट द स्टैंडर्ड डिविएशन, स्टैंडर्ड डिविएशन अगर लगाता हूँ ये तो 3.5 से ले लो, राइट, 3.5 माइनस 3.6 स्क्वायर plus similarly, right, so zero point 0.1, so
हाँ.
0.01 plus 0.01 divided by 2, so
हाँ.
0.01 हो गया, are you getting it?
लेकिन अगर, तो भैया अगर मैं इसमें से हिस्टोग्राम हटा दूं,
हिस्टोग्राम का
अगर
तो
इस
पर्पस
क्वेश्चन में
सिर्फ उसको
इसमें
कह रहा है कि कंस्ट्रक्ट हिस्टोग्राम, वो दिखाने के लिए कि अच्छा तुम्हें ऐसे आ जाएगा, हाँ निकाल दो हिस्टोग्राम, निकाल दो, एग्जैक्टली वर्ड हिस्टोग्राम निकाल दो वहां से,
histogram is just showing that 3.5 is occurring the maximum number of times. अच्छा, okay. And you're getting a normal distribution because he's doing it a million times.
so this over and over makes it
नहीं,
the key thing, हाँ
over
बोलो
and
बोलो,
over makes this fact that it is a normal distribution, and 3.5 is the central tendency. तो अगर मैं इफ आई रोल द 10 डाई 10 स्टैंडर्ड डाई, ठीक
हम्म।
है, मैंने 10 स्टैंडर्ड डाई रोल किए, सो
हम्म।
व्हाट कैन बी द एवरेज इज 3.5.
हम्म।
What is the standard deviation? Standard deviation is 2.9 divided by under root of 10.
नो, वो
Okay,
कहाँ से आया?
यहीं तक.
नहीं नहीं, वो एक बार 10 सैंपल लिया तो उसमें से नहीं कह सकते। बार बार लेते रहे 10 10 का
तो
सैंपल।
उसका कैसे?
जो एवरेजेस आई, सपोज एक बार एवरेज आई 3.3, दूसरी बार एवरेज आई 3.4, फिर आई एवरेज 3.7, ये जो सारे हैं,
हाँ,
इनको अगर मैं इनका एक एवरेज लूं, इन सारों का एवरेज बनता है एनीवेज अपने को पता 3.5, पर
हाँ,
वो कब बनता है? जब ये बहुत सारे ले लेता हूं। When I take a lot of them, it becomes
ओके,
3.5, right? अब मैं 3.5 से ये सारे
हाँ भैया,
सब्ट्रैक्ट करता हूँ, right? So then, and I take the standard
हाँ,
deviation of this line basically, right? So this data, if I was to take the standard deviation of this data till here, right? Okay,
हाँ,
that it will so happen that the standard deviation of this data would be is can be easily computed without actually knowing this so much of data, can be easily be computed by looking at the property of one of those repetitive, the smallest unit of the you know thing, which in which case it is a die
repetition,
roll.
okay,
So the probability of die roll was some sigma, let's say. So the probability of sorry, the standard deviation of the die roll was sigma. Now I'm using sample size of 10. Then this will become sigma upon square root of 10. This is a mathematical proof, a pretty
mm-hmm.
long one, but is applicable only for central limit theorem, where I'm saying I'm taking it multiple times. Otherwise, if you were to take a standard deviation, let's say you just roll it two times, then it becomes 3.4 and
Mm-hmm.
3.3, 3.3 and 3.4, right? So average,
Mm-hmm.
what would be the average? It will be 3.35, right? So if I was to take the standard deviation,
Okay,
it will become 0.05. Actually, zero point 0, this variance would be
yeah,
clear on that, no? So 0.05
okay भैया,
square into 2, and then I take the root of that, so that is square root of 2 into 0.05. So the whole
okay,
idea is that I take so many data points that eventually I know that it will end up getting it will become a normal distribution. And we know once it becomes a normal distribution, then we know it mathematically. We know that mathematically this normal distribution will be such that it will have mu and sigma by square root of 10 as its two mu and sigma parameters,
okay,
right? So
okay
this
भैया,
whole thing came from the concept that we are doing it over and over again.
okay,
Typically what we do is we say, okay, we take the samples say about 10, 100 times also, or even if 10 times, right? So we assume that, okay, because one sample would not be any different from the other, they should mathematically follow the same concepts, right? So expected value will be the same. So expected value of the variance will be still sigma upon square root of 10, and that's why we end up using it. So
okay,
so our answer here would be, right? So he's doing, the answer will be point, since the variance of the sample distribution of mean is, he's not gone into an explanation anyways. Chalo. So we're done with this. Let's look at the last question. Okay, now this is also an interesting question. All right. The number of web hits to a site is Poisson with a mean of 16.5 per day. What is the probability of getting 20 or fewer in 2 days, expressed as a percentage to one decimal place?
P boys,
No, yeah, fine. People is fine. But let's look at the math behind this first. A little bit of, or the logic behind it, not the math. What is it that we want to find out?
probability, cumulative probability of getting 20 or fewer in 2 days. So I forgot question.
Let's look at how the Poisson distribution graph looks like. Uh, all right, so the Poisson distribution graphs tend to look like this. They tend to be like normal distribution as lambda increases. All right, lambda is basically the mean in a particular unit of time, right? So let's say 10 cars passing a particular point of the road uh, per minute. All right. So and as lambda is lesser, this has a different shape. As lambda increases, tends to have normal kind of a distribution. Okay. So that's just to give you an idea. So now what he's saying is, if suppose let us say this was the case, right? So okay, right. So if this was the case, he's saying that the mean is 16.5 for one day. What is the probability of getting less than 20 cars in 2 days? How do you solve this?
लैम्डा उसने दे रखा है ना तो number
Okay,
of
let me
candidates
put it
and
this way.
batches.
Can we say it this way?
Lambda is mean there.
Okay, lambda is mean. Okay, fair enough. Lambda is mean. Yeah, given to us. So lambda is given to us, right? And that's the mean, which is 16.5. Okay. So now he says 2 days may 20 or fewer, less than equal to 20, right? But that's 2 days. This lambda is for one day. Now this is for 2 days. What do we do?
Yes.
Shall we divide this by two?
No, no, वो No, not divide by 2.
Then
Uh,
what do we do? How do we compare them?
since 2 is like number of days. एक मिनट 20 20 or fewer in 2 days. So K is 2 ना नहीं
What is k?
K is K is the number of occurrences, which is 20.
K is the number of occurrences. Let's say okay. Then what next? Let me show you what how p poise goes. So then it will become more clear for you, right? Just a little bit of r. So then we'll come back to this question.
10 minutes up.
So if I say p poise, right? Now p poise has inputs. One is q, another is lambda. So let's say a simple case of lambda being 10. I say 10 comma 10. I get a probability of 0.58, which means 10 or lesser vehicles passing, let's say, or right in this case web hits. If 10 is the web hits per day and 10 is the per day, let's look at a simple case of one day, right? Not 2 days. What I'm doing is this. Let us solve this case for one day first, right? So I'm saying 16.5 per day, and let us look at a simple case of 16 in a day, right? What is the probability of getting 16 or lesser in a day? It should be around 0.5, near to that, because the so I say
बट ये तो भैया टोटल से है ना कि मतलब
let us look
अगर
at this,
इवेंट
right?
होते जा रहा है
हाँ हाँ देखो, तो ये 0.5 के करीब आया। क्यों आ रहा है? क्योंकि मेरा अब मैं सपोज इसमें से सो ये पी पॉइंट इस तरह से आता जा रहा है, समझ रहे हो? अब मैं सपोज 16 की बजाय 10 लेता हूँ, मतलब बहुत कम चांस है कि 10 आए एक्चुअली, राइट? अगर एवरेज 16 आता है, 16 पीपल आर गोइंग टू बी on an average, then it's too low. So that's what we get, only 6% chances that 10 or less than 10 will be hitting the website. Okay, so that's how p-poise goes.
Mm.
In case I was to end up taking it as 20, then the probability would be almost 1, right? 100% chances. Are you getting this? So, but it still is just
Mm.
83%, right? So, if I make it say 22, I get it as 92% chances. Let's say 28, almost 99.6% chances. So, average is 16.5. 99% chances are there that 28 or lesser than 28 hits will happen, right?
In infinite time.
No, in a day. The mean was for a day, right? 16.5 was per day,
So it is for it's for a day.
right? So it's the same unit basically. Both of these parameters should be the same unit. Q as well as lambda should be of the same unit. No, otherwise it doesn't make sense. No, it doesn't
Okay,
really make
okay,
sense,
okay,
right? When I'm talking about probability, at least something I have to keep common. No, same experiment repeated again, basically,
okay, bhai.
isn't it?
Mm.
So this is what I'm getting. So if I was to draw this plot, I would get some values, right? Say 8, I get only 1.6%. So, but then what do I do? Now the tricky part here is 2 days. He's saying it is 20 in 2 days. 20 in one day, I would have been just straight away saying, okay, give me that's my answer. 20 in one day gives me this answer. So 83% chances of getting it, right? 83 point or 84% chances. But he's saying 20 in 2 days. What do I do now? So shall I say 10 per day?
Sum of poison.
Shall I take 10 per day? Shall I take
No,
10
bhai.
per day?
It can be one day, 19 other day. No.
Right, right. Good point.
Poison process होता है ना.
Right, good point. So you're saying it could be 19 one day and one day and still it makes 20. That's what you're saying, right?
हाँ, anything can happen.
Anything can
Yes,
happen,
bhai.
any combination of that can happen, right?
एक दिन.
S- Perfect. Excellent. So, excellent, right?
Poison
So,
process भैया जो होता है वो मतलब I did it long time.
right. So probability of till 19, let's say, in one day, right? एक दिन में till 19 आ जाए, right? is 0.77. Then अगर 19 तक आ गया, तो दूसरे दिन में उसका माइनस आना चाहिए, राइट? से
Yes,
अगर
bhai.
एक बार 18 आया तो दो आए, राइट? मैक्सिमम दो आए, नॉट मोर देन दैट. So I have
हाँ.
to mix and match, right? For everything, it's a pretty long process,
Yes.
right? So I'll have to do all of that, right? So I have to say, okay, 18, 2, 17, 3, and so on. Say probability of 17 in one day. So what I do is, so let's do it this way. Uh, Plus probability of 3. Now, but this whole thing has to be divided by what? 2,
Uh,
right? 17 or less, or 3 or less.
हम्म.
So again,
Multiply
it
नहीं
will be
होना चाहिए भैया.
yeah, multiply नहीं होगा. It'll be slightly tricky actually. It will not get multiplied because this is exclusive, this is separate. The probability of getting 17, wait, sorry, how it will be is,
नहीं.
anyways,
मेरे
basically,
हिसाब से.
let us look at it this way. If you're saying, so now what are the possible combinations? One is 0, 20, 1, 19, 2, 18, and so on till 20, 0, right? So
हम्म.
we have to do all these probabilities. What is the probability of getting a 0 in one day, right? And so if we got 0 into one day, it will be multiplied. This multiplies and added, right? This addition. ये सब multiplication होगा.
भैया मैं सर्च मारा तो वो बोल रहे थे कि सम ऑफ टू पॉइजन uh, processes is a Poisson process with lambda is equals to the sum of the two lambdas.
हाँ वो ठीक है वो
So
that is the
we
solution
can
that
take
I'll come to
30.
finally. I am just
Okay, okay, okay,
I'm coming to that. That's an easy solution. But if we were to just
okay.
look at this, right?
Multiply, yes, yes, yes.
Are you getting this? So but this
Yes.
is again only 20. This will only take out of 20. It has not taken all this summation multiplication kiya. It is just taking care of probability of 20. What about the probability of 19? Probability of 18? Overall over 2 days. This whole thing is only probability of 20 for 2 days. Probability of 19 कैसे आएगा? P0 into P19,
How?
right?
Okay.
And so
What
on.
number?
Then P1, such a tedious thing, right?
Yes,
Pretty
sir.
tedious. How do we go about doing it the easy way? We say that how the Poisson works is this way that, okay, fine, this is from first principles and we are correct and good thinking. I would say at least you thought about it, right? And because this is what we want to finally calculate. But we are saying that, look, this is such a tedious process. Poissons will tell you one more thing. What we can do is, so how I can solve this is I can say 20. So Poisson, if I was to take the Poisson for 2 days, right? This is 16.5 per day, right? So then it will become
Mm-hmm.
33 for a 2 day window. So
Two
my mean
days.
will be 33 for 2 day window. Is this clear?
Yes, sir.
So my 1 day window was 16.5. Then the 2 day window will straight away become 33. That is the mean.
Yes.
Are you getting
Yes,
this?
sir.
So if I just say
Yes,
P
sir.
poise 20 comma 33, I get my answer.
33. Yes. Round one. ठीक है भैया sir.
Correct? So
Hmm.
this will take care of the answer rather than doing it with 16.5 here and then trying to create 10 into 20 200 combinations or rather more. Clear?
Yes, sir.
Let's say P poise 20 comma 33. All right, and lower rotate is equal to 2, so 0.0104. So that is effectively in percentage it is 1%, right? So let's look at the answer. It says 1. He's just multiplied it. Clear? Are we done?
Hmm. Yes, sir.
Okay, so itna kafi hai. We still have these homework number 3. Homework number 4 is the most interesting, in fact. It will clear. In fact, मैंने वो hypothesis वाला सिखाया तुम्हें कि नहीं?
वो मैं वीडियो मुझे देखना है एक्चुअली आई मेरे रिवाइज करना है आई डोंट नो अबाउट दीपांकर वो एक मिनट अभी टॉयलेट गया वो आ रहा है
ठीक है. आई थिंक इतना काफी है आज के लिए तुम लोगों के लिए.
he's asking is it enough for today.
Maybe you can do one more 10 question. Minutes up.
Yeah. So basically, I
Yeah,
thought
as per
why I ended up here is that second homework is complete. We can move on to the third one now. So it says, okay, let's look at it. The third one. The first question is load the data set empty cars in the data packages. Calculate the 95% confidence interval to the nearest MPG. What is the lower point of the interval? What is the upper point of the interval? Okay, so what is he saying? Let's
95
look at empty
confidence.
cars, right? So let us look at empty cars. So this has calculated 95% confidence interval to the nearest MPG. So there's a there's this thing called miles per gallon. All right. So there are 32 observations, and then there's miles per gallon data, right? So when we're saying calculate the 95% confidence interval, means what? He's not mentioning about the he.
Normal distribution, right?
Yes. So we are assuming it's a normal distribution. First thing, right? So secondly, it will be 2.5% on both sides, right? So what we have to do first is, so we calculate the mean and the standard deviation of this data. We say mean of what's our data first. Let's say X that I'm interested in is
empty car.
empty cars
Okay.
dollar mpg. Okay,
MPG.
this is what I'm
Some
interested in.
mean.
Okay, I say my mu is equal to mean of x,
20.09.
and my s, which is the standard deviations, the approximation of the standard deviation is sd of x. All right, so now,
Huh.
so the 95% confidence interval will be given by, uh, how do I do that? Let's look at it. Let's solve it here. 2.5%,
Yeah, do for standard deviation.
2.5%, right? How do I normally get this? So
2.5%.
I say
Yes, yeah.
mu and how many standard deviations
SD.
away this is, right? So typically, how it is done is
Hmm.
mu, uh,
Minus sigma over zero.
no, no, no. Say, let
Mu
us say,
minus.
let me call this lower tail value, uh, let's call it ml, mu l. So the xl, right? So I say xl minus mu divided by sigma,
Divided by sigma.
right?
Equals x.
This would
Z.
make it normal distribution, right? Then this is equal to q norm of 0.025. Is this clear?
No way, ये समझ में नहीं आया.
Okay,
Yeah, but see, basically it will be left of this tail.
Okay.
right?
So
This will
what
be
we
given
have
by,
done is taken the left of the tail, which is q norm 0.25.
this is the probability, right? Q norm will give me that value here. How
Let's.
many standard deviations basically,
हाँ. Okay. Okay.
right?
Okay. Yes.
So
Yes. Yes.
how many standard deviations into that standard deviation? So my XL basically is nothing but mu
Okay. Yes.
minus sigma into Q norm 0.025, and my XU, that is upper, here would be similarly mu plus sigma into Q norm 0.025. Is this clear? So these,
Why this now? No, I don't agree with this.
Q norm
okay,
is gives
No,
what?
when there is this, sorry.
The Dipankar is asking something.
right, good, ask, go ahead.
Why no, you added sigma into q norm 0.025.
Hmm.
Does this mean you're taking the other side, the right side?
The lower one, upper one you're clear about. XL is equal to mu,
Upper one is clear because
okay,
it's on the left.
right, the left one actually
And
is what?
plus, we know the probability of that,
Perfect. So look at the lower
and
one.
you can do it.
How would
Yeah.
that be actually the lower statement? It will be, let's do it this from this side to this side, right? So I say x upper xu minus mu divided by sigma. This has to be some positive value, right?
Yeah.
Right. So this is how many standard deviations away. I have to take a value here, right? So this would again be the same because the area is the same. This is anyways.
Should be 1 minus 1 of that. I mean,
mm,
1 minus that on the right hand side.
Uh,
no, no, that's why we took the plus here, no? We've already incorporated in by taking the plus here. Let us
plus
say,
minus क्या है?
wait. Let's just,
Ah, okay, okay.
right? So,
But the thing is,
uh,
uh, the mu L which you
actually,
marked
wait,
is on the
actually, what will
left,
be,
right?
right? So, this region, right? So, we are just interested in this point here, right? So, this point is attained how? It is at Q norm of 0.975, actually,
Correct.
right? So, at 0.975, that's it, right? So, Q norm of 0.975 into uh, sigma. So, basically, I've,
म- मुझे डाउट हो रहा है कि क्यू नॉर्म की जगह यहाँ पे जेड वैल्यू आनी चाहिए ना.
वही तो z वैल्यू तो है,
Yeah,
यही तो z
the
वैल्यू है,
हमारी
करेक्ट.
z वैल्यू
Excellent.
है.
This is what is z.
Z वैल्यू.
Z value is nothing but q norm of a normalized distribution. Sorry, standard normalized distribution. Let's look at it. Let's just show you.
okay, okay, अच्छा
See,
अच्छा क्यों
each
ना.
normal distribution
Okay,
has its
fine.
own standard deviation
Right?
and mean,
I say
right?
q
Fine,
norm
fine. मेरे को लग रहा था
of 0.99,
point.
2.32, right? 0.996.
हाँ.
कितना
तो
जहां पे 3 आता
actually
है,
I was thinking.
ये
हाँ
देख,
भैया सही है,
पॉइंट
सही
नाइन
है.
फाइव पे आ गया ना 1.64. यही होता था ना 1.64 स्टैंडर्ड डिविएशन अवे,
हाँ, हाँ
right?
भैया हाँ.
So that's what it is. Basically,
हाँ.
Q norm of where mean is equal to zero and standard deviation is equal to one is nothing but the Z score,
Said right. Okay, okay.
right? So that's all. So I'm just so let's just do this mathematically now, no, using R.
हाँ, हाँ भैया.
So what are we interested in? We are saying uh, my mean is what? I say X, right? Plus. So how do I get this plus minus one? I say minus one, comma one. All right. Into uh, standard deviation. So that is S into Q norm. So both ways will work. Either I can take Q norm of 0.025. This will also give me the wait mu. Sorry, right? So I get two answers. At the same time, if I was to make it as 0.975, I still get the same two answers. Is it clear, Dipankar, now?
Yeah.
Basically, either I can just multiply it
Yes,
by
sir.
0.025, I get 31 and 8 as the answer. When I multiply it by 0.975, I get 8 and 31 as the answer because it gets basically overlapped, interchanged, right? So that's going to be my answers here.
Yes, sir.
So let's see if this is the lower point is 8.278, upper end point is 31.90. Let's see if this is correct. Wait, 18. What is he doing? Round t test. Why is he doing a t test? We don't want to solve it using the t test. We would want to solve it as it is. Where did we go wrong? Standard deviation and our mu is 20. Load the do library. Consider t test for the
10 minutes up.
Why is he doing the t test? I guess this should be the answer that what we have calculated. Can you figure out why should he be saying the answer is 18 and 22? I don't see any reason.
Okay, wait, do we have to multiply?
What we can try it
समझ
out
नहीं
is
आया.
length of x क्या
Sets
है,
R
32.
package का वैल्यू कौन कौन सा है? इंटरवल पूछ रहे हैं. नहीं, हाँ इंटरवल तो होती है. नियरेस्ट है एमजीबी. नियरेस्ट क्या होता है?
And that's what he's doing. He's taking the square root of 32. Right. So what is he saying here? He's saying that
It's not normal. It's T distribution ऐसा.
no, not t distribution. That is he is dividing it by the square root of n, where n is the number of data points. There are 32 data points there.
हाँ
If I
भैया.
say str of empty cars, right? So it has 32 observations, all right? Or simply saying, if I say length of x, it has 32 observations. So what he's saying is, okay, fine. So what is empty cars? Basically, that's just a sample, right? It's a sample from the population. Is this clear?
Yeah.
Yes,
So
sir.
it's a sample from the
Yes, sir.
population. So sample size is 32, and the standard
Hmm.
deviation of the sample comes out to be, so if you remember, let me rephrase this. We saying this our sample size is 32, all right? And that's not actually the population. He is interested in the lower endpoint of the interval for the population, not of these empty cars. Then his answer is correct. Otherwise, our answer is correct. All right. So when can we say normal distribution?
नहीं
See,
मैं
32 data
एक
points
बार
doesn't
रिपीट
create,
करना जो आपने लास्ट टाइम बोली.
right. 32 data points is all what we have. If we were considering this only as our
हाँ
data and nothing else, then 32 data points doesn't create
हाँ.
a normal distribution.
नॉर्मल डिस्ट्रीब्यूशन.
On the other hand, if we say that these 32 data points actually belong to a huge population, and I'm picking up some data points here and there, and they form my sample, and then what I want to answer is the for the sample, right? So for the sample will again have a normal distribution. And how do we, what do we tell about the normal distribution that is created by the sample? It is estimated. The mean of this
ओके.
normal the mean is estimated by straight away the mean of the data, right? In which case it will be mean of x, all right?
सैम एक्स यस.
And standard deviation, how is that estimated? Standard deviation, we know is standard deviation of the population divided by the square root of n. But the standard deviation of population is not known to us because we don't have the population.
हाँ.
What can we do? We can approximate it by the standard deviation of the sample,
सैंपल
which is what we calculated.
divided by the
And then we divide it by square root of
square
n.
root of n. Okay.
So that is what he's using here. So this will give us a range of the empty cars data, correct? So he's saying what's the lower end point of the interval with 95% confidence, and what's the upper end point of the if not really of the empty cars. I don't, his question is ambiguous here. It would not be the right thing to say. It should be that if such samples were taken with what is your, and say empty cars is conveying one such sample, what would be the confidence levels? What will be the confidence interval? Is this clear now?
Yes, sir.
Yeah. So basically, how we are able to use it is because we had actually some data now. So we're not just talking about just pure mathematical concept. We actually pulled out some data and we applied statistics on it, and we're coming up with some answer. All right, of predicting the value in a way. Okay. Suppose that the standard deviation of nine paired differences is one. What value will be the average difference have to be so that the lower endpoint of a 95% student T confidence interval touches zero? Suppose, give the numbers here too. Suppose the standard deviation of nine paired differences is one standard. Okay. What value would the average distance have to be so that the lower endpoint of a 95% student's T confidence interval touches the zero? Let's forget the T confidence
Lower
interval. Let's
input.
assume normal for now. Okay, Z score only. We will come to the T interval little later. Right. So what are the things here? We're saying, let's say, assume assume it's a normal distribution. Okay. So he's saying, so he's taken nine paired differences. All right, and the standard deviation is one.
Yes, sir.
Right. He's saying what is this mu? Okay. So this is one such that lower
हाँ.
endpoint touches zero. Lower endpoint of a 95%, lower endpoint is this, right? So lower endpoint, that means upper endpoint and lower endpoint. So which means this is 2.5%. This is equal to zero. So this point equals zero and standard deviation is one. What will be this mu? Right? And then because it is not a normal distribution and a t distribution, we will use another z score basically. We will use, instead of q norm, we will use qt, right? So we will end up using qt of 0.025, first of all, right? So that'll give us, well, it'll give us how many standard deviations away it is, and then we get this answer,
हाँ ओके.
right? So let's say
और
qt
मैं
gives
वो
us some value r, right? So
निकाल लेते हैं ना भैया.
हाँ, समझ गया ना, मैथमेट
हाँ.
so how do we solve this? So qt of 0.025, wait, sorry, we'll have to give the degrees of freedom. So now degrees of freedom in this case would be 9 pair differences, right? So
8.
8, right?
हाँ.
Mm,
Minus
minus
2.3.
minus 2.3, right? So basically I think 2.3
हम्म.
would be the answer because standard deviation is 1, no?
हाँ राइट. हाँ भैया.
2.30, right? What would be the average difference have to be? I hope कि इसमें वो square root of n वगैरह से वाला divide वाला चक्कर ना रह गया हो. Suppose that
वो क्यूटी में करके अपन ने शायद ले लिया ना.
QT में तो आ गया,
नहीं नहीं एक
परसेंटेज से आ गया, right? That has taken care of it. Now what we are saying is standard deviation, he's saying is 1. Suppose that the standard deviation
भैया
of
9
9 pair
पेयर
distribution,
डिफरेंसेस.
that is S, right? That is just the S. Then we may need to divide it by
अंडर रूट ऑफ 8.
square root. नहीं, वो नहीं, I think यही होना चाहिए. Let's just try this out. 2.3. हाँ, वही कर रहा है वो, right? Degrees of freedom, ये same आ गया, and then 1 by n divide होगा ना. So we are saying 2.3 divided by 1 upon square root of n, that is 3. 6.9. QT of, isn't it symmetric around the mean? QT of
ये तो
0.97.
सिमेट्रिक तो होता है
हाँ,
भैया.
ये तो symmetric है ना. So this
हाँ
part is
सर.
correct. Into what is he doing? He's just straight away dividing it by 1 by 3. Why is he doing that? What is that answer? Into,
डिवाइडिंग इट बाय 3.
why is he dividing it by 3? करेक्ट, वो
अंडर रूट
2.3
ऑफ
थोड़ी लेना
9.
था. वो तो जो भी आंसर आया उसको ही 3 से डिवाइड करना था. मैंने गलत कर दिया, उसको 3 से
नहीं
डिवाइड करना था रादर मैंने
वन तो.
मल्टीप्लाई कर दिया. जो हमारा सही था पहले, जो सेम 2.3 आ रहा था ना, 2.3 डिवाइडेड बाय 3, दैट बी द करेक्ट आंसर.
नहीं भैया मैं ये बोल रहा था
10
कि
minutes
वन
up.
वन जो है वो 9 पेयर्स का स्टैंडर्ड डेविएशन है. तो
राइट,
इट ऑलरेडी इंक्लूड्स डिवाइड बाय 3.
नहीं ना,
इज इट राइट
वही
और
चीज,
नॉट?
इट इज नॉट. दैट वन इज द सैंपल. लेट्स कम बैक टू दिस पार्ट. What is that one? That one is equivalent to, remember we said that sigma upon square root of n. But because we don't know the sigma, we know this s.
हाँ
That s is given as 1.
हाँ.
And we also know this n, which is
ओके ओके
9.
ओके.
So the standard deviation will actually be s upon standard square root of n, which will be 1 by 3.
तो दिस.
Yeah.
नहीं माय पॉइंट है सिग्मा सिग्मा बाय अंडर रूट ऑफ एन इज इक्वल्स टू एस नहीं होना चाहिए क्या?
No, 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 no.
बिकॉज
Sigma, wait, look at, understand this. When say what is it that we actually have? We have some population, all right? We don't even know the distribution of that population. For simplicity's sake, let's assume that that
ओके.
population has a normal distribution. This population is supposed to have a mu and a sigma, all right? In most of the cases, we don't know both of these. We don't know the mu, we don't know the sigma, all right? What do? We say
राइट.
that based on the central limit theorem, if I take a sample out of it, let's say my sample size is n, then the sample,
हाँ
if I was to take uh, uh, the this standard deviation of the sample. Note, it is not the standard deviation of the sample. It is called the uh, squared errors. All right, sum of squared errors basically. It is right. So in effect, that is what it is called.
अच्छा.
So that will give me some value s, or rather, for simplicity's sake, let me say it is the standard deviation of the sample. Okay. Now that is, how is that related to the sigma? We are saying that this s is an approximation of the sigma. All right.
Okay.
This
Okay.
s is an approximation of the sigma, but at the same time, if I was to take the mean of this sample, right? So I had n, right? I was actually take the mean. This mean, and if I was to keep on taking many such samples, then these samples will all have some mu and some standard deviation. We know that this mu will be still the same as the population mu, and this standard deviation will be sigma upon square root of n. But we don't know the sigma. We approximate it from one sample.
Okay.
We don't know this mu. We approximate it from the mu of the sample. So that's what sigma is
Okay.
equivalent to s, not sigma. S is not equivalent to sigma upon square root of n. Is
Okay. Okay.
is this clear? So remember this
Okay.
important concept
So,
that s, that is the approximation, is equivalent to sigma. To make it more clear,
अच्छा अच्छा ओके.
population size,
तो
maximum
मतलब the
is, let's say, this much, right? This has some standard deviation,
हाँ ओके.
right? If I was to take
Right.
1,000 data points out of this, I would get some standard deviation, let's say s. Now this is an
हाँ.
approximation of this. If I was to take 10,000 data points, I would get, say, some s2. This is again an approximation of this. If I was to end up taking all the data points and actually calculating, I get s3, which is exactly equal to sigma. So as n increases, s approaches sigma.
Right. Right भैया.
Clear?
ऐसे
But
छोटे से.
if we are to take the average of these values, right? I take an average here and I do such many such data points, the standard deviation of that would be given by sigma, that is the population, this thing, upon square root of n. But because we don't have any approximation of this, we don't know this value, we replace it with s.
Yes.
Clear?
Okay.
Where s is the
हाँ.
standard deviation of the sample. So that's what. So this is how we get the
Okay.
correct answer. So this is also clear. Okay.
Yes भैया.
Okay. An independent group students t interval is used instead of a paired t interval. When? When the observations are paired between the groups. Okay. Read through this and tell me. The observations between the groups are naturally assumed to be statistically independent. As long as you do it correctly, either is fine.
The
More
independent group
details are needed to
assumes
answer this question. The observations are paired. Hmm.
the independent group of students T interval is used instead of paired interval independent observation.
As looks like a very obvious question. I haven't gone through this question myself. I think this should be the answer, right? When they're independent, that's it.
हाँ second. Yes.
Correct?
क्यों
Huh?
बोल रहा है independent
हाँ.
यहाँ पे उसमें. Yes.
So consider the empty cars constructed 95% T interval for MPG comparing 4 to 6 cylinder cars. Assume a constant variance. So I think we just need to perform the T test part here. Did I go through in the class T test for you guys or no? I don't
I mean,
know.
I didn't see the video. Sorry.
Okay. So I think then in that case I need to kind of explain the T test because otherwise it doesn't make sense. Because all of these questions are not from fundamentals, they are all from T test.
एक second. टी टेस्ट
We'll have to study and come for next time.
नहीं भैया ने वीडियोस में कराया था क्या?
T-test.
हाँ पहले मतलब पहले क्लास में कराया था भैया ने.
Multi long term.
I doubt मैंने करवाया
है
होगा because मेरा
दीपांकर.
my whole focus was on the fundamentals,
Okay.
right? So I don't think I have covered it. Let me say we'll probably cover it tomorrow. But the fourth quiz that is there, sort of the fourth part, again it involve, yeah, it's more of hypothesis testing, but hypothesis testing still comes from fundamentals. So all of these questions are prob-
Okay. Wait.
so I think that we can stop it here. तो आज
ठीक
के
है
लिए
भैया.
इतना ठीक है. अच्छा तो कैसे, हाउ डू यू वांट टू प्रोसीड, मतलब सम वेट, लेट मी जस्ट स्विच ऑफ माय रिकॉर्डिंग.